Yes, it is visible and audible. So with that confirmation, let me proceed then. I hope all of you are following the textbook also, network management, which I shared here. Please go through the slides as well. Okay. Okay. All right. So in the last class, we did discuss about the SNMP version 1. Let me quickly recap it. So we started with the SNMP, Organization and Information Model. What is that standard and history related to that SNMP version 1? Started in 1990 and then version 2 came in 1995 and 1998 the version 3 came. Okay. Then this is one of the very popular standard network management protocol which is used across the globe. So we have this any network with this TCP/IP protocol suite is an ideal candidate for the SNMP management. So even non-TCP/IP management oriented network also could be used with the help of proxy agent. So that is the advantage of this. So any devices which are connected to the network can be managed with this SNMP protocol, right? So there is an SNMP manager is there, SNMP agents are there, which are sitting on top of the network element, and then we can do that. Okay. So now between the agent and the manager, the communication takes place that is through the SNMP protocol. So this communication is basically through the SNMP protocol. So which is going to be talking about this entire thing. Then we have the somebody is messaging. I don't know what is that. Let me read. Okay. Pathan. So he's telling good morning, sir, all. So I got confused. What is that all? It's okay. This is how it looks basically. So if you look at the pictorial diagram, this is how it looks, and the LAN, in terms of LAN, it looks like the right hand side picture. There will be a manager for the entire thing. So here is the managing entity. Rest of them are all managed elements, so they will be placed with the agent on them. Now anything to be communicated, so that is through the managing and the agent. Manager and the agent, it takes place. Okay, so that is the concept behind this. So again, query and acquire information on the system parameters. So that's what exactly SNMP does. So there are four types of models are possible. One is organization model, information model, communication model, and the functional model. So based on the like what we call SNMP model, we have this hierarchical structure. So sometimes it's also possible to that more than one manager can be possible. So we call it as the manager of managers, like that. So two-tier organization model, which contains the SNMP manager and the SNMP agent on the network element. So both of them can start communicating that. Sometimes more than one manager can query the same element through the agent and can get the related stuff. That is information can be obtained. So SNMP manager basically arm on probe and then the managed objects. When we have a RMON is called a remote monitor. Remote monitoring. Somebody. So what happens here, instead of network manager continuously monitoring the event, so we can also go for an option called the remote monitoring, which is called as the RMON. This will be inserted between a managed object and the network manager, so that manager can do something else, which is important thing. So this is being an remote monitoring. It can keep on monitor the things. There are multiple versions are there for the RMON, RMON 1 and RMON 2 that we will discuss post midsem. Okay. So again, with respect to the hybrid fiber coaxial, etc. So there could be a non-SNMP managed things, and there are SNMP managed elements will also be there. So keeping that in mind, so SNMP manager will communicate to the non-SNMP managed objects through the proxy servers. That's the. So if you look at the communication as such, if you consider the TCP/IP model kind of thing, SNMP generally sit on the application layer. Below that is the transport layer. Below that is the network layer, and then the data link layer, then followed by the physical layer. On the other side also physical layer, data link layer, internet or network layer, followed by transport layer and the application layer. Now the SNMP agent application is sitting as on the managed element, right? So that is how it looks. Now there is going to be a communication happen between the manager and the agent in such a way that, so get request, get next request, set request. These are the three messages sent from the manager to the agent. And similarly, agent will respond back to the get response and trap through the two more communication things that will be done by the messages, communication messages which are going to be exchanged between the. Okay. And there are four services: get, set, get next, and trap. Whereas five messages are there, that is get request, set request, get next request, get response, and trap. This is how the services are going to be explained in detail. So then the information model will going to have a MIB and the SMI. So the managed object can be considered as to be a composed of an object type and the object name. Structured management information is concerned only with the object type and not the even object instances. You can have multiple object instances, but it is worried about only the object type. Okay. So object, object type, object instance, name, object identifier, syntax ASN.1, encoding BR. So object type as name. Every object type is uniquely identified by a descriptor and an associated object identifier. Example, internet object identifier. Then syntax is as per the ASN.1 and basic encoding rule will be applied here. This is how it will be placed. You can have a look at here. So one stands for directory management, then the experimental, private, then enterprise, like that. So there are primitive data types like integer, acted string, object identifier, null. Then defined data types like IP address, counter, gauge, then time ticks, opaque are the things. So basis this, we also looked at some of the IP entries or keywords Then the with respect to the basic encoding format BER rule, so we use TLV, type, length, and value. Value is just nothing but the data. So type again further will have a class PRC and that tag number. So seventh and eighth bit are going to be the class which are going to be defined as four categories: universal, application oriented, context specific, and the private. So 00 is universal, 01 is application, 10 is context specific, and 11 is the private. So then we have a PRC, stands for primitive or constructor. So 0 for primitive and 1 for the constructor. Then we have the tag. So again, tag will have something like a TLV format. So this tag numbers are going to be little different. So which is going to be based on the hexa values. So tag are going to be integer means 02, octet string means 04, object identifier means 06, null means 05, and sequence of is 30, IP address means 40, counter is 41, gauge is 42, time ticks is 43, and opaque is 44. These are the like what we call the hexa values. So now the encoding structure for an integer 32-bit integer 14 value. So that will be represented as a integer means 02. So tag will be 02. Then length is 4 bytes. So it will take the length is 4 bytes. Then the value is 14, right? So 14 is represented in ASCII equivalent, hexadecimal, which is going to be E0E. So rest of all zeros, only the E will be the things. Similarly, you wanted to send a high. So ASCII equivalent of H and ASCII equivalent of I will be considered. Again, when you are sending the octet string, the tag will be 04. Length will be high means 2 characters. So length will be 2 bytes. Then the value will be high ka, H ka, ASCII equivalent which is 48, and I ka ASCII equivalent which is 49. If you want to use object identifier, then the tag will be 06. Length will be 4 bytes because 1.3.6.1. So then the value will be 01, 03, 06, 01. That's a similarly IP address. If you want to store 131.21.14.8. So IP address again, the tag code is 40. So 40 will be stored. Then length will be 4 bytes. So it will take it as a 4 bytes. Then what is the 131 ASCII equivalent, X equivalent, which is 21 के लिए 51, 0 E for 14, and 8 for 8. That is how it will be stored in the text. And the MIB structure, which is just nothing but the contain the entire structure in the format of ASN, that is abstract syntax notation. That's what we discussed in the last class. Is any question so far? Since last class, you have any doubt, you may ask. Okay, if no more questions, then probably we will move on to today's discussion. Hope all of you have received the quiz, right? Quiz 3. Please check, guys. When we get lab sheet, sir, before that I asked the question. So did you get the assignment 3? Lab sheet. Actually, they said that it will be delayed by 1 week when we had in the last meeting. I don't know why that delay is not sure. Hmm. Anyway, I'll put it in the group. Mm, Shanmuka, I'll put it in the group. Let us wait for the reply once they get. So we can do that. Let me do it right away, otherwise I may forget. Good that you reminded. I was completely out of that context. It's generally, we will not receive any such information. Citation. Okay, I posted in the group. Let us see. Somebody will respond for that. There I are. Okay, let us start today's session now. So we are talking about SNMP version 1 protocol operations. So, and also we look at the both the communication and functional models and the protocol operations in this lecture. So maybe you can start installing the simple net SNMP configuration and the things. Install a graphical MIB browser and then load the various MIB and understand the capabilities of the MIB browser. Then also, so Wireshark tool is there. So maybe you can explore those particular Wireshark tools. So we have covered the, I think even we are supposed to get the that what we call lab access, because through the lab only we can able to demonstrate that Wireshark tool, because on my system I do not have the Linux operating system, because Wireshark, I don't know whether it is there for Windows network environment or not. But anyway, I think last year also I did with the help of that whatever the lab access they gave. So on that we installed. Today also we will wait for that. This time also. So far we have seen the organization and information model. So now let us look at the communication and the function model. So what was the functional model, which is just nothing but the F caps, like fault management, configuration management, application accounting management, performance management, and the security model. The same, I think today also I'll touch upon the last thing because it also talks about the functional model. The functions are actually built in the community-based access policy of the SNMP administrative model. So communication model basically talks about the information between the network managed stations and the network managed elements are going to be exchanged. So that is exchanged through the communication. For that communication, we use a messages. So basis these messages, we will going to exchange the things. The goal of the management function is maintained by the agents, which are kept very simple. And there is also a flexibility in terms of protocol. So where you can add new aspects of the operation to the management. And also the communication should be very transparent, should not be affected by the architecture of a particular host and the gateways. So as we discussed in the last class also, there are 5 messages are there: get request, get next request, set request, get response, and the trap. So SNMP messages are exchanged using the UDP, connectionless transport protocol. It helps to understand the administrative relationship among the entities that which are going to be participating in the communication protocol using SNMP. As we know already the architecture, we have a SNMP manager and the SNMP agent. The pairing of these two entities is called as SNMP community, and the simplest form of authentication is the common community name given to that. Okay. So administrative information, performance, some statistical study, and monitoring the traffic on the elements. So SNMP is authorization is implemented as a part of the managed object in the form of MIB specifications. A management agent may be permitted to view only the subset of the network elements managed by the community MIB view. Each community has also assigned an SNMP access mode, either read only or read write mode. Then the SNMP agent with read write SNMP access mode can perform the operations like get, set, and trap, and which has only a read only access mode privilege can only perform the get and trap operations. That's the restrictions here. The data protocol data unit, which is exchanged between the two as a part of communications, includes like get request, get next request, set request, get response. Like we have a PDU, we call it. That PDU is called as a protocol data unit. The SNMP protocol data unit will have version, community name, PDU type, request ID, error status, error index, and the variable binding list. So the version of the SNMP message, version is just nothing but the version of the SNMP message. There are 3 versions of the SNMP: version 1, version 2, version 3. So community name is a string of the name of the community from where PDU is originated, and this is can be of a length up to 255 characters. PDU type contained SNMP message, get request, get next request, set request, get response. Then request ID would be the unique number that is used to distinguish between the different requests which are associated with the corresponding thing. Then error status is used to indicate that an error occurred while the agent was processing a request. Error index is used to provide additional information about the error by identifying which variable in the list has caused an error. Then variable binding list, which is just nothing but the grouping of number of operations in a single message. Example, one request to get all the values and one response listing for all the values. So this is how it looks like user datagram protocol, source port, destination port, simple network management protocol version 1. Community is public, data get request, request ID is 5, error status no error 0, index is also 0, variable bindings 1 item, right? So like that there will be a details which will be given to, and the same will be encoded in the form of like this. The blue color one indicates, no, that is the. Then we have the SNMP, as I told you, it's been message is a sequence version. So that is 1.0. So community acted string data PDU. So 3 different versions, version 1, 2, 3, as I told you. Then we have the PDU's choice get request 0, PDU type. Okay, PDU type will be 0 for this get request to, 1 for this is called the get next request to, 2 for response, 3 for the set request, and 4 for the trap. That's how the PDU type will be identified. Then error will be error status, no error, too big, no such name, bad value, read only, general error. So these are the 5 types, 6 types which are possible in the error status. Then error index is just nothing but an integer corresponding to that. So variable bindings are going to be the name value corresponding to that. So sequence of this will be called the variable and bind. Similarly, that last class we discussed about the TLB, right? So similar fashion it will be used. This is the message. So finally, this entire thing will take a thing like followed by the community name, which is going to be public, then followed by the PDU type, enterprise object identifier, network address, then the what we call trap type, specific trap type, timestamp, variable binding list. That will be the. So overall, if call it as an encapsulation of this entire messages keeping put together, we have the entire message looks like this. So SNMP manager or agent performs the following transmit PDU, that is construct a PDU using ASN.1, pass the PDU for authentication. Okay, and then once that authentication returns a PDU that is encrypted, the protocol entity, then create the SNMP message by adding the version field and the community name of the to the PDU. Message is encoded using the PER, that is basic encoding rules, and it will be transported to the request. Now an SNMP entity manager or agent performs the following upon the reception of an SNMP message. The receiver performs a basic syntax check. Message is discarded in case of error. Verifies the version number, message discarded if there is any mismatch. Authentication if supported, it provides the message, does not authenticate. So we'll have the trap and discard messages are going to be generated. So finally, using the community name, the access policy is selected and the PDU will be processed. The sender include the following information like PDU type, request ID, variable bindings, and all the list of object instances whose values are requested. SNMP dictates that the scalar object is identified by the object which is concatenated with the 0, which distinguish between the object type and the instance of the object. Again, this is not, instance are not important, but the object type is important for the. So system will be having system description, object ID, system uptime, system contact, system name, system location, then system services. These are the information which are available in the midglobe. So maybe then get request. So you can request for any of the information. So get request system description dot 0 indicates that the scalar value should be retrieved the scalar objects only, like that. Then get response sun operating system. Then get request for the object ID. So it will going to represent return with the enterprises dot 11 dot something like object ID will be written. Then get the system time up system time. Get that. Get the request the system contactor. It will respond back with the system contactor. Get the system name. It will going to give the network operation NOC1. Then get the requester sys location. So it will going to say nothing, null is there. So get request system service dot 0, which is going to be 72. Like that, the manager and the agent process will be executing the or exchanging the messages. The manager could have used only one message to obtain the values of all the objects under the system group using a variable binding list. So that is also possible. So only one message, it will give all the information related to this. Get request is atomic, either all the values or no values kind of thing. Error message is generated if at least one of the variable could not be found, then error status will be no such too big general error, those type of things. Error index indicate the problem, the object variable in binding list and caused the problem. With the SNMP, only leaf objects in the MIB can be retrieved. So leaf objects in the sense in this picture, you have seen like these are the leaf objects. So leaf objects can be retrieved. The management station has to include each object instance in the binding list so that you can get the information. So get request PDO, IP route destination, IP route metric 1, and then the IP route next hop. These entries will be done in the table. So based on the get request, so this is the IP route destination metric IP route next hop. Then we have the SNMP protocol operations. So like as we discussed, SNMP operations consists of two types, very important, listen carefully. So SNMP operations comprise of the get and set messages from manager to the agent. Get and set from manager to the agent and get and trap from the agent to the manager. Correct? Get and set, because get request and get next request, set request. These are the three messages which are sent from the manager side, and this agent will be sending get the response and the trap. So the network management system software runs on the NMS servers to implement the following: send request SNMP agents on the managed device to query or modify the variables, and will also receive the SNMP traps from the SNMP agents on a managed devices to learn the device status. SNMP agent, an SNMP agent is process running on a managed device. It maintains the data on the managed device, responds to requests from the NMS, and returns the management data to the network management system. The agent performs the required operations in the MIB and sends the operation results to the NMS. If a fault or event occurs on a managed device, the SNMP sends the agent sends an SNMP trap containing the current device status to the network management system. The managed object is just nothing but an object to be managed on the network device. Any managed device may contain multiple managed objects like a hardware component and the parameters configured for the hardware are a sum. A MIB contains the variables that manage the device maintenance, and the MIB defines the attributes which are going to be managed by the device, including like name, status, access rights, and data types of the managed objects. Of course, MIB uses the tree structure to store the data. A tree node indicates the managed objects, which is uniquely identified by the path starting from the root. So the path is called as an OID, object identifier. That's all. Like this. Root, further this thing will be. The object ID of the system is 1.3.6.1.2.1.1. Means it will be root ISO, then organization, DOD, then internet, then management, then MIB, correct? So in that system, like that. If you want to access the interface, then OID will be 1.3.1.2.1.2. That's the kind of syntax. If you want to say ICMP or TCP, then the numbers will keep on changing. The SNMP GET operation, the network management system can send a GET request to SNMP agent to obtain the data. Agent executes the corresponding instructions in the MIB and sends the result to the network manager. Now GET request, SNMP agent will respond back. Get next request, response. Get bulk request, response back. Like that. Get bulk is not in the SNMP version, but it is there in the version 2 and version 3. So SNMP get operations will NMS can send a get request SNMP to an SNMP agent to obtain the data. SNMP agent executes the corresponding instructions in the MIB and sends the result to the NMS. This is the get packets. So IP header, UDP header, then followed by version, community name, SNMP, PD. So for next get or get next video looks, video type, request ID 00 variable by index. Get bulk, this is the thing, response, this is the format. Again, version could be a version 1 or 0 for 1 or 1 for this, like that. It will going to change. Community name, again based on the public or private, etc. which is just nothing but a 255 characters. Request ID specifies the ID of each request which is being made. Non-repeaters are maximum repetitions. See, get bulk is something like a repetitive, no? So for that, it has to, how many times it has to repeat. Error status, if error has occurred or not, then error index specifies the index of an error. Variable binding specifies the list of variables, names, and corresponding values. This is how the request operation from the system group. Then the get next request operation. So sometimes generalized case is a where a sample MIB contains both scalar values and the aggregate objects, retrieving scalars as well as aggregating objects using the get request and get next request is also possible. This is how it looks. Get request A, then response to A. Get request B, response to B. Get request T dot E dot 1 dot 1. Like that, you can get the all the related to that. Okay. So there is something called as the objects are retrieved using a lexicographical order. What is lexicographical order? So it is something like a dictionary order, we say. First we go number order 1, then 1. Number order 2 means 118, which is going to be based on the lexicographical order. Okay, what is that we will see. Start with the leftmost digit as a first position. Before increasing the order in the first position, select the lowest digit in the second position. Continue this process till the lowest digit in the last position is captured, like when you are talking like this. 1, right? 1.1.18. That's the kind of thing what we have. So now if we go for this particular thing, path 210.1. So this is how it looks. Start index table, which is corresponding to that particular IP route matrix. Then next stop IP route destination address. This is a next request, get next request, get next operation. Okay. Advantage of this get next operation is that we do not need to know the OID of the next entity. Automatically it will be fetched in the, because it's a sequence of, right? So in the sequence you can get what is there in the next item. In the case of aggregate or tabular object, the number of rows may be dynamically changing so that we do not know how many rows exist in a table at any given point of time. This is how the Wireshark capture for the get request. So you will have that frame 5209 87 bytes on wire, it is 696 bits. 87 bytes are captured on interface 0. Ethernet 2 source address is something like this. Destination address something is like this. Internet protocol version 4, IPv4, source is this, destination is this. User datagram protocol is being used, source port number is this, destination port number is 161. Then the protocol name is SNMP, version is version 2C. Then we have then we have this community, which is demo public. Data is get request. Get request ID is this much. Error, no index error, also 0. Variable bindings, 1 item. So this object value. That's how I'm going to give the value. So where share capture for response 2 bar 3. Community as password. So if there is a trap like this, okay. Now data is trap 4. Here it was telling get response. Here also get request. So likewise you have a trap के लिए. This is the so SNMP set the NMS can send the request to the SNMP agent, and in order to complete the configurations on the managed devices, after receiving a request, get set request, the SNMP agent executes the corresponding instructions. So that the MIB can send the result to the network management system. Using the SNMP set operation, the NMS can configure one or more parameters for an SNMP agent, indicating that you can set the response. Then the protocol operation, so which is going to be again based on what you will going to do. Set request. Trap means, so SNMP traps are the notification messages sent by an SNMP agent to inform the network management system of alarms or alarming that event generated by the device. Now administrator can learn the running status of the device in a timely manner. There are two types of SNMP traps. One is trap and inform. SNMP version does not support the inform request and inform response to send an alarm or event to the NMS by the NMS agent. Similarly, like enterprise agent address, generic trap, specific trap, timestamp, then variable bindings. These are the SNMP PDU with respect to specific to trap. So now the same thing like SNMP data is trap. So trap from the enterprise so and so agent is this much, generic trap is this much, specific trap 1 timestamp at what time it has been done. So date and time will be there. So then variable bindings, which is just nothing but the 4 items. All the 4 items can be taken into. So SNMP communicate with the 2 port numbers. What is 161 and 162? So 161 is used when the NMS sends a get next, get bulk, and the set request, and the SNMP agent responds to these requests. So this port number is configurable and ensure that the port number used by the NMS to send the request packets in the same as that used by the SNMP agent to respond to the request packets. Port 162, this port number is used by the SNMP agent to send the traps or inform the messages to the NMS, and this port number is configurable. Ensure that the port number used by the SNMP agent to send the traps or inform the messages in the same as that used by the NMS in order to listen to the traps or inform the messages. Polling frequency. Few traps are going to exist in the standard. Thus, most of the management informations are gathered by the means of the poll. Get request and get next request. Polling is done infrequently. The management stations may have outdated view of the network. So congestion might happen and network management may not be alerted. So if polling is done frequently, the control messages overhead will be high and degrade the performance of the system. Polling frequency requires some policy definition. So as per the size of the network. Assumption that assume the management system can handle only one agent at a time. When a polling an agent, MS does no other work until it is done. Polling may involve a single get or response transactions or multiple such transactions. So which can handle the number of agents, considering it the engaged in a full-time polling only. N less than equal to T divided by the delta. Delta is the average time required to perform the single poll, desired polling interval, and then the N stands for the number of agents. So again, delta depends on the multiple factors like processing time, network delay, processing time at the agent to interpret the received messages, processing time at the agent to generate the response corresponding to that. Then there could be a network delay from agent to manager, processing time at the manager to interpret the message, and the number of request or response transactions to obtain all desired information. For example, say device on a LAN, each device is to be polled every 15 minutes. The processing time would be 50 milliseconds. The network delay is equal to 1 milliseconds. So there is assuming that no congestion has happened. So n less than equal to 15 into 60 divided by delta, which is equal to 4500, where delta is equal to 50 plus 1 plus 50 plus 50 plus 1 plus 50, which is coming around 202 milliseconds. So that's in a WAN network, it could be little hmm, varying. That is based on the data rates in the WAN, which are sometimes less than the LANs. Distances are greater, delays are higher, example 0.5 seconds. Delay introduced by the bridges and routers are also to be considered as a part of this. So get the if in actors and if out access of the MIB2 interface group. So with this, utilization is equal to C2 minus C1 into 8 divided by T2 minus T1 into bandwidth, which will give you the percentage of utilization. Anyway, lastly, I think we have covered the functional, that is FCAPS, fault management, then the configuration management, account management, performance management, and the security management, which is forming the network, functional model of the things. Okay. So lastly, let us look at what are the limitations of SNMP version 1. So SNMP may not be suitable for the management of a truly large networks because of the performance limitations in the polling. And SNMP is not well suited for retrieving a large volume of data, such as an entire routing table. Then SNMP traps are unacknowledged and may not be delivered sometimes. So SNMP provides only a trivial authentication, but it is suitable for monitoring rather than the control. Okay, rather than the control. SNMP does not support explicit actions. An action is taken by changing a parameter or setting an object value. SNMP does not support manager to manager communications. Many of these problems are addressed in the version 2. So that's all for today's thing. If you have any questions, please ask. Meanwhile, let me stop recording.